here on 3. So we're all in agreement with 3, right? So when you multiply, you add your exponents. And it doesn't matter whether they're integers or rational numbers or even what they are. You just add them, okay? So 1/2 and 1/2 is 1, which is what the exponent is on A, or some people like to turn this into a radical, because that's what the square root means. I mean, 1/2 means a square root, and you could write that like this. And these two guys, when you square something and take its square root, they undo each other, just like adding and subtracting, multiplying and dividing. That's one way to see it, or you could have simply said it's 1/2 plus 1/2, which is a to the first. There's lots of ways to see that, okay? So that one is true. Okay, so the last one seems to be the one that has the most, like, variation in terms of the answers, right? The most disagreement. So someone want to argue T and someone want to argue F. Yeah, Alexis? Right, I is not a real number. So there is no real number that you can square, right? I won't put an equal sign there. There's no real number you can square to get -16. Right. So this is what we call 4i. And we'll deal with that in a little bit when we get to quadratic equations. Okay. So this one is true, false, or is it true? It's true. All right. That's true because it is not a real number. It's an imaginary number. And then this first one, do we have agreement on this now with table 5? Yeah, are you okay with it? So all this says is, look, I'm still 2 to the 4th, but I'm downstairs. That's all I am. I go downstairs. I'm unhappy being upstairs in the numerator because right now you could write that like that. Wants to go downstairs. Okay. So this is false. Okay, so let's start today's lecture. And thank you for all the people who came in with questions and put them on the board. You got 2 points on your little daily thing. And I will encourage you to continue to do that, because that's a way we can sort of, I can see where your questions are, and hopefully it will help other people with the same questions. Okay, so who wants to start us off? Nathan, you want to start us off today? Okay, so we're saying that the area of this square is 25 square units. So imagine that this is 1 square unit. So what does this mean that this particular square has an area of 25 square units? What does it mean? Yep, Brendan? Right, that I could fit 25 of these little squares in here, okay? So I would have 25 of these. Well, this is S, and S is, doesn't have a number to it. But there would be 25 square units. It's a 2-dimensional measure area, and it's always measured in square units. So where do we get the idea of this term square root? Where does that come from, square root? Well, hopefully you think in your mind it must have something to do with a square. Okay, so the length of each side of this square has to be 5, because 5 times 5, or 5 squared, would give us 25. So that's the same thing as saying, what is the square root of 25? When you're looking for the length of the side of a square, that's equivalent to saying what's the square root of whatever your area is. So in this case, we're saying the area is 25, and you can represent 25 as 5 squared, and therefore our answer, which is the length of the side, is 5. Now notice, anytime you have a square and a square root, they undo each other. Okay? They are inverse operations. One undoes the other. Okay, just like when you're solving a baby old equation and you're you add things to one side, or you multiply both sides by the same thing, or divide. You're trying to undo what's happened. So the square root undoes the square. Okay. So a little bit of language. Right here, we've got some new language coming up. Excuse me? Square unit. That's one little baby square unit, right? So someone want to start us right here, the radical symbol? We'll go right around the room. Is it Ryan? Andrew, sorry. Right where the highlight is?
Radical symbol, square root is usually non-negative square root of square root of.
Right. So most of us just say the principal square root of a number. Principal meaning like main, or, you know, I don't know how you think of principal. It was always a scary guy to me when I was in junior high, but this principal, or the non-negative square root. Non-negative, remember, means 0 or anything to the right is 0, right? It's the non-negative. It doesn't say positive, it says non-negative. In general, all positive numbers have how many square roots? Does anybody know the answer to that? 2. So in other words, if I ask you to find the square roots, notice I'm plural, of 25, there would be 2 answers. There would be 5 and negative 5. One of them is positive and one of them is negative. Okay. The only exception, just like with those sometimes always never questions we were doing the other day, is the square root of 0. It only has 1 square root, and that's the number 0 itself. Right, it's neither negative or positive. So you say, okay, if this symbol right here is going to give me the positive answer, square root, if I use that symbol, that's telling me find the positive square root. How do I indicate the negative? That's right here. You just put the negative outside of the whole thing like you do with any number when you want to say the opposite. You put the little dash out in front. So this always means the principal square root. And most of you are just going to call it the positive because you're going to forget about 0. You're not going to go around saying the non-negative square root. And this is how you write the other square root of 25, which is negative 5. Now, we can't do a physical interpretation of that with a square with a side of negative 5. But mathematically, there are 2 numbers that you can square to get 25. Okay. Any questions on that? I want to point out something right here because this is something that really drives algebra students crazy. Notice, if I want to square a negative number, I have to put it in parentheses. Have to. Because these 2 things are not the same. And that's something we go over in like a Math 096 class or a 106 class. This says square negative 5. Okay, negative 5 times negative 5, boom, 25. That's what that says. Okay, that says this. This says take the opposite of 5 squared. The base here, the base, thing that's being squared is negative 5. The base here is positive 5. And there's a negative 1 outside the whole thing. So that means negative 25. So you got to be very careful when you're representing a negative number being squared. You must put these parentheses or else you're going to have a false statement. Okay? That's just one of those little things you just got to kind of get somewhere. Okay? It just is one of those things that plague you. This little dash sign kind of starts plaguing you around introductory algebra when you're trying to distribute it through, and you know, it's kind of a pain in the butt, but we get there eventually. Okay. Any questions just on covering the basic idea of squares, square roots, positive square roots, negatives before we move on? Anything at all? this pretty like review for most of you? Yes, no, it's okay? I mean, should I continue to do this like next semester? Or should I pull this out of the lecture notes and just go right down to here? What do you think? Should I just go down to here? Go over it? Okay. All right. So like I said, I'm rewriting these lecture notes from scratch. So any kind of feedback you can give me would be great. Okay. So, you know, this, like in anything, you've got language that I'll be saying. This little n, this root you're taking, you can take a square root, a cube root, a fourth root, a fifth root, any root. That little n we refer to as the index. That's the index. What is the index? If it's a cube root, it's 3. If it's a fourth root, it's 4. We already talked about this symbol being the radical sign. And the whole shebang that's underneath the radical sign, the whole shebang, whatever that is, could be one simple expression like x, or two, or a whole mess of stuff. It's called the radicand. Okay. That's the whole shebang. Okay, so notice I have a little table here. We've got some numbers, and then we have 2 columns. How do you write the positive square root and the negative square root? And then symbolically, we can represent this with a plus and a minus. So you have to remember that when you're trying to take the square root of a real number, you always have 2. That's important when you solve quadratic equations, to remember that, because you're going to fall into the habit of just thinking about one answer. Okay, so square root of 144, you got to know your times tables. 12. Therefore, the negative square root would be just 12 with the dash in front of it. And then you represent plus and minus square root of 144 as plus and minus 12. We already did this one on the board. Jonathan had put this question up. This is the square root of 16 divided by the square root of 25, which is 4/5. So this will just be negative 4/5. And then over here we write plus or minus 4/5. Okay, how would we write the positive square root of 7? Square root of 7. There's nothing else we can do, because what kind of number is it? Irrational, right? 7 itself is prime. That's correct. So this is a prime number. If, you know, we didn't talk about that. It's also a rational number. And once you take its square root, it becomes irrational. Okay? Some of us have our moments where we're fairly rational, and then before you know it, we're irrational, right? Okay? So applying the square root to some numbers makes them irrational. Okay? So the negative square root would just be with a little dash out in front like that, and that's irrational. And then to represent both square roots, you just put the little plus and minus sign out in front. So again, that's referring to the positive and negative square root. Okay. Negative 49. Tell me all of the different sets that negative 49 falls into in terms of what type of number it is. We can go from the smallest to the largest set, or just any kind. What are all the different sets that negative 49 belongs to? What kind of number? Yeah, okay, integer. Is it an integer? Yes or no? Yeah, okay. It's definitely an integer. What else is it? Okay, someone other than Brendan, but he said it, so rational number. It's definitely a rational number, yes. Someone else? Yeah. It's, yeah, that deals with the integer part. It's negative 49 is the opposite of 49, which is a counting number or a whole number. Its counterpart makes it an integer. So that's all the integers, okay? And it's real, right? So all of these, the big group that all these live in is the real numbers, right? Okay. But it is negative, and that's kind of what we meant by this integer, because the integers bring in the negative side of all the numbers, 0, 1, 2, 3, 4. Okay. So now if I write this, the positive square root of negative 49, what's my answer? 7i. It's not a real number. So for right now, we just say not real. No real number, because right now we're just dealing with the real numbers, not real. Okay. Okay. So there we go. Again, the number stuff is important. We talk about it a lot in math, and it takes a little while to get all the terms down. Okay, so let's move on. And again, this is, let's see, what sections were we dealing with today? Notice what I have up here. Exponents in scientific notation, self-review. That's section P2. That's self-review, all your exponent rules. Those can drive you crazy. I've got some kind of cool ways to remember them. Well, I think they're kind of cool. I made them up last semester. I don't know if Haley liked them, but do you remember them, Haley? No. Okay. So I guess they weren't too memorable. But I have some ways to, if you're one of those people who have trouble remembering rules, I have some cute little mnemonic devices for exponent properties. I'd be glad to share them with you in the studio or come into class or my office sometime. So that's self-review. That's where you read the section, take some notes as needed. You're all in different places. Some of you haven't been here for a while. Some of you just took math this summer. So you're all in different places. Radicals and rational exponents we are covering fairly thoroughly today. Okay, so that's section P3. All right. So find the following square roots. So do you see what the square root of that number is there? Can you see the number that's being squared? Can you imagine a square with a side, a length of a side? Can anybody see it for A? What would be the length of the side for this square? What would be the square, the length of the side for that square? 8, because the area, the thing underneath, is 8 square or 64, right? Most of us like seeing it this way, and we don't make a relationship between this number and this number right away. But the reason why we can say the answer here is 8 is because, to both of these, is because we can write 64 as some number squared. It's 8. It makes a square that's 8 by 8 or has an area of 64 square little units. I could take 64 square units and cover that square. Okay, so that's 8. And again, I'm just trying to get you used to this idea. The square root and the square undo each other. Yep, you can do that. Yep, absolutely. So what's the answer to this one? Still 8. But what was the number being squared? -8. So what is a mathematical concept that takes a number and makes it positive no matter what you do to it? Yeah, Brendan?
Negative times negative is positive.
Yes, that's an operation. What concept? I'm going after something else. Okay, still an operation, not a concept. We looked at this, I know it's a little tricky, I'm asking a very open. We looked at this concept in Wednesday's class if you want to sneak a look back at Wednesday. So what did we do Wednesday that turned a number into a positive number no matter what we did? Yep, absolute value, right, right? Absolute value is a concept because what concept does absolute value deal with? What's the concept behind absolute value? Yeah, distance from 0, right. So the conceptual idea for absolute value, the conceptual idea is distance from 0, right. Anybody see the Red Sox game last night? Whoa. Oh, if you're... No, that was the night before. They beat the Yankees in extra innings 9-8. If you're a Yankees fan, keep it to yourself. No, I'm teasing. You can be a Yankees fan. I've gotten over it. 9-8. Distance from 0. I don't know why I was thinking of that just now. I should be focused on teaching, right? Must have had something to do with being positive or something. I'm trying to stay positive about the Red Sox. Oh, really? Charles River?
Yeah.
Do they do that, really?
Yeah, they did that when I was little.
Oh, really? Did you have a Yankees hat on or something? Oh. Oh. Oh, do they? Oh, that's funny. Oh, I didn't know that. I'll have to remember that. All right, so what is the mathematical? All right, so the whole idea here is that when you see the square root of a squared, you have no idea what kind of number a is. A could be like this, 8 being squared, or it could be -8 being squared. You don't know because a is a variable. Unless, like in Math 106, our books always said, assume X is positive. Okay, so we kind of got away with it in Math 106 or 096. But now we're not going to assume anything about A. So when I write the answer here, what should that answer be so that it covers me in both of these situations? What should I be writing there for the answer? And that's a really good, I didn't think about that, Jonathan, but what does that symbol ask us to find? Which square root? This is our principal square root, so our answer's got to come out to be what? Positive, okay? If it had a dash out, a plus or minus, then we could put both of them, okay? But remember, when we use this square root, our answer's got to be positive, but yet it's supposed, what if the number that goes in is negative? So how am I going to say, I can't just say A here. I can't put an A. Cecilia? Oh, it's Cecily. Sonia and Cecily. Okay. All right. So what do I do here? Absolute value of A. Right. Okay. Now before, in Math 096 or in other classes, you might have been able to just say this, A. But remember, if A was -8, this was -8, the answer wouldn't be itself. It wouldn't be -8. It would be its opposite. So that's why you got to put it in absolute value. Yep, Logan?
Still not exactly clear on why. So if you had -8 squared.
That's 64. That's 64. And this says find the principal square root of 64, which is +8. Because that's what that symbol means. No, if you come back here, this symbol is used to denote the non-negative square root of the principal square root. Always. And that's why this down here is the negative square root, because you take the opposite of a positive number. Okay? So the key here is that when you have a square root, and you'll see later on, any even root, anytime you have an even root with a variable underneath, we're just going to be dealing with numbers now for a minute, you have to use this absolute value. And your book's sticky about that. They'll show you answers that have the absolute value. Okay? So you just got to remember, we're not just dealing with positive numbers anymore. All right, so that means down here somewhere, there's somewhere on here. Did I put another answer key in here? Well, I'll find it. All right, so let's see if we can find the pattern. So at your seats, work through 5. At your seats, we'll come together and talk about it. So the cubed root of 5 cubed, cube root undoes cubing. They are inverse operations. Cubing undoes cubing. Correct. That's the same thing as saying this. What is the cubed root of 125? What number do I cube to get 125? Well, it's staring at you right in the face. It's 5. 5 is what I cubed to get 125. What is the cubed root of -125? Because that's what -5 cubed is. Now remember, I said pay attention to whether your index or your root is odd or even, because they act differently. Notice I had up here that we have to put the absolute value because this is an even root. The absolute value applies to even roots, square roots, fourth roots, sixth roots, not odd roots, because we can find a number that we cube to get -125, and that is -5. It's right there. So this has an answer. It's -5. Okay. Now, here, they undo each other. The answer is 5. And here, these are both the same. 5 and the absolute value of -5 are exactly the same. You can put an equal sign there. So you could have left the answer like this or like this. It's not a variable. So it would have been fine to just put a little baby 5 there without the absolute value. But it's also good to remind yourself, I think Alexis did this, yes? It's also really good to remind yourself that it's the absolute value of that base because it's even, yeah? Is it Lisa? Liza, I was close. Yeah. 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 Hmm. Oh, okay. So, well, there's going to be always like little things like that in any program. Like WebAssign always wanted you to make like the variable you were solving for a capital and the other one little when you typed it in. And it was just something you had to learn. Those are like, as you go along, little things like that, I will write down, so tell me, and then I will put it like on a sheet for next semester students. So I love hearing stuff like that. Any of the little, what do they call that, idiosyncrasies of a program. So that's a good thing to know. Thank you. And if you find any other ones, let me know or just email me. That's probably the best way for me to remember. Okay. All right. So either of these is acceptable. Now we're doing an odd root again. So 5 and -5 is the correct answer. Even root, 5. Absolute value, it wouldn't be, even though these are equivalent, I would prefer to see here either 5 or absolute value of -5 because that reflects what's here. But these are all equal. So it wouldn't matter whether you left it like this, or like that. Okay. If it said the 6th root of x to the 6th, you have to put the absolute values there because you have no idea who x is. It's like the mystery person behind the screen. All right. All right. So here's our big conclusions. And I think I've got 2 107 classes back to back. So I'm not sure if I told you this on Monday or, oops, am I recording? Yeah. But Ian started this whole thing, Ian Winokur, about memory and how you can remember large quantities of information. Like he was able to memorize this whole long email that President Pura sent out word for word because he learned a memory technique. So I started reading the book he read, and then he gave me some other stuff. So we're trying to do these like cutesy, they're kind of cutesy little things like the Beatles reunion for the union idea, right? Just something that maybe you can hold on to. Now, these things may make sense to me or Ian, and they may not make sense to you, so you might have to develop your own. But this is Ian's version of that memory game. So if n is odd, and you're taking the nth root of a number, do you have to worry about what you put here? Can you put a, or do you have to put absolute value of a if n is odd? You can just put a, because it's going to look just like the number that's being raised to the nth power. If it's positive, it will be positive. If it's negative, it will be negative. Okay, because it's odd. Okay, so this could just be a. Well, let me write the a better. Okay, so then Ian made up this little phrase. We end up where we started. If n is odd, don't modify. We're not modifying it in any way. We're not making any additions to the answer. Odd, modify. Get it? Cute? All right. You like that? Good, Tiffany. If n is even, then what would the answer to this one be? Absolute value of a. We end up with a positive number. If n is even, absolute value gets its revenge. And in the word revenge, you see even. Okay. Okay, we do whatever we can to help you out, right? Hey, all right. So let's find radicals was one area I know when I teach math 106 or 096 as it's now called. Radicals is the one area that always can get students a little bit. A radical can be written as an exponent. So a square root, if I write the square root of 4, that's the same thing as 4 to the 1/2 power. That's what a radical means, like the square root. You write it as a fraction. Roots go in the cellar, right? We're getting ready to harvest all our roots out in the farms, and we can store them in our cellar. So the root here, the square root, you notice the 2 appears in the denominator. Okay, now, so all of your exponent properties apply to multiplication and division. So anytime you have a radical, since it's just another way of writing an exponent, the same properties apply to radicals that apply to exponents. So if you take the square root of a product, it's the same thing as taking the square root of each individual factor. It's not an adding and subtracting problem, it's multiplication. So this goes both ways. When you write this, when you write this kind of thing, it goes both ways. Doesn't mean you have to start out with it written like the square root of 9 times 4. You could start out with the square root of 9 times the square root of 4, and you could write it all under one roof. Doesn't matter which direction you go in. Okay, so if we had it this way, your order of operations is going to tell you to do your multiplication. Well, your order of operations is going to tell you to do exponents first, right? So this is one area where those order of operations is a little funky. Because you're going to do this multiplication first, and then you're going to say the answer is 6. Now, you could put it in absolute value to remind yourself, or you could leave it as 6. You could do each individual factor and still come up with the same answer. That's no problem. Okay, so here's the product rule for square roots. And this is, bless you, this is exactly the same as the exponent rule. The exponent rule that applies to a product. Here, the only difference between this exponent rule and this product rule for square roots is one is written as an exponent and one is written as a radical. Because that n, in this case, can be represented by 1/2. So it's just the same thing as what you've been doing with exponents all along. AB to the n equals a to the n times b to the n. The exponent applies itself to each one of these. And that's what you see happening right there. The radical applies itself to each factor. Logan? No, it's a to the n times b to the n. Right.
No, I get that. I just mean, like, is it multiplied to the exponent or is it additive? So, like,
oh, it's multiple. It's a to the first to the n. It's a to the 1 times n, which is a to the n. I got your question now. Okay, good. All right. So how do we simplify something like this? Square root of 400. Is 400 a perfect square? You say, how the heck do I know? I don't know. But, you know, let's see. Is there a number you can square to get 400? Does anybody know? What is it? Oh, 20. Some people know that. What if you didn't know that? How could you start to simplify it, Eric? All right, so stop right there. He said the square root of 100 and the square root of 4. So basically, in his mind, he's breaking up. He's doing this. He's making 400 into a multiplication problem. AB here is like 100 times 4. And then what did he do? He's taking the square root of each one of those individual factors, 10 times 2, and then he gets the 20. Okay? So most of us, we probably don't know 20 squared is 400. Maybe some of us do. We're good at mental math. But when you're given a number like 400, what you need to do is say, can I find a number that will divide into it? That's a perfect square. So on the side of your papers, you should make a note like this. This will be very helpful to you of, say, I don't know, the first 12, 13, 14 perfect squares. So what 64 is 8 squared, 9 squared is 81, 10 squared is 100, 11 squared is 1. So if you go, 13 square is what? 169, is that right? What's 14 square? You don't know? Okay, well, you can figure out. What about 15 squared? 225, so it's something in between there. What is it? 196, okay. So these are just numbers you should recognize as perfect squares. They'll help you. Okay, so let's take a look at B for a minute. See, B, we're starting on this side, right here. It's already been broken up for you, right? But they didn't break it up in a very helpful way because you can't take the square root of 6. Square root of 6 is irrational. Square root of x is getting you nowhere. You need at least 2 x's, x squared, to simplify it. So they've busted it up for you, and you don't like it. So throw it back together under one roof and start all over again. Okay, so that's why I said that arrow goes both ways. So rewrite this under one radical symbol, 6x times 2x, and then do your multiplication and start all over again. Okay, so now you say, okay, I'm going to do just like I did on part A here. I'm going to bust this apart. I'm going to take the square root of the 12, and I'm going to multiply it by the square root of x squared. All right? And what did we say the square root of x squared was going to be? Nope. Absolute value of x, right? They just cancel out, but it's even root. You got to put the absolute value. So only thing we got to deal with now is how do we represent the square root of 12? So can you write 12 as a multiplication problem? Not 6 times 2, because that wasn't helpful at all. 4 and 3, because 4 is what kind of number? Perfect square. Okay, so we get 4 times 3, and that's the square root of 4 times the square root of 3. That's 2 square roots of 3. Square root of 3 is irrational. Square root of 4 is rational. So then we write our answer like this. That just comes out in front of the whole thing. It goes in absolute values. Doesn't matter where it goes. It's a multiplication problem. You can write it like this. You can write it like this. You can write it like this. Oops. That's a 3. This is a multiplication problem. The order doesn't matter how you write it. The only thing under that radical symbol is 3. 2 is all by itself, and the absolute value of x is all by itself. And which order you write them makes no difference to me. All right? So one time in life, I'm flexible. Yeah, Sonia? Where? Right here? Here's the answer. I'll come down here. 2. There it is. Okay? Sorry. I thought I have kind of clear handwriting, but. Okay, so I want you to try these two at your seats. And then I think you got a group exercise, right? To end the class? Oh, no. We got to move along here. Hang on. Forget that. I'll let you on there. The quotient, and we already did the quotient over there. So let's get rational exponents. We just talked about them briefly. What does 64 to the 1/2 power mean? Square root of 64, right. So this is just our way of saying this. Okay, so this answer is 8. 64 to the 1/2 is 8. And let me show you why that works. And this is what students often won't do, but you can rewrite 64 as 8 squared. And now you can apply your exponent rules. Because what do you do when you have a power to a power? What do you do to your exponents? Do you remember what you do with those exponents? You multiply, and 2 times 1/2 is 1. So you just come right back to 8, right back to the base. And as Tiffany noted, that's why those two things cancel each other out, because one is the 1/2 power and one is the power of 2. And 2 times 1/2 brings you back to 1. So you're just left with whatever your base is. What does 64 to the 1/3 power mean in radical form? Cubed root of 64. And what's that answer? 4, because you can write 64 as a perfect cubed. It's 4 cubed. These two guys undo each other and you get 4. Okay, so in general, when you see a to the 1/nth power, it's a to the 1st power. We don't usually write that 1 there. And the index is n. So your root is the same as the index. Your root goes in the denominator. Roots go in the cellar. Okay, and now generally if you have 8 to the 2/3, I'm going to show you several different ways to do this, and you pick whatever makes the most sense to you. Some students like to do it this way. Some students will convert this to a radical. They'll do this. I'm taking the cubed root of what's left. Once I pull this 3 out of here, I have 8 square left. Once I take care of my root, I have 8 square left. And then you can say the cubed root of 64, and we just said that answer was 4. That's one way to do it. Another way to do it is to do this. Take your cubed root first and then square it. Because 1/3 times 2 is 2/3. So your cubed root of 8 is 2, and then square it. Okay. it's usually easier to take your root first and then apply your numerator, the exponent in the numerator. And here's one other version of that same problem. You can rewrite 8 like this. And now you can use your exponent rule right here. You can multiply those and you get 2 to the 3 times 2/3. Your 3's cancel out and you get 2 squared, which is 4. There's so many different ways to do these exponent, evaluating these rational exponents. Some students have their method that they like best. Some like to do this kind of thing. Some will do the root first and then apply the exponent. Some of you might think about this. This tends to be probably the least familiar one. So in general, when you have a base raised to the m divided by n, that means the nth root of a to the m. Oh, the -1. What does this mean? What if we know 8 to the 2/3? If we know 8 to the 2/3 is 4, what is this answer going to be? 1/4. It just says, put me on the bottom. I'm the reciprocal. Has nothing to do with negative numbers. So 8 to the -2/3 says, take my cubed root. Take my cubed root. Oh, keep getting the wrong. I'm trying to hurry here. Take my cubed root. Kavanaugh. Then square me and then flip me. That shouldn't be a negative there. So those are the 3 actions you're doing. Cubed root. You're squaring, that's your numerator. And then you flip reciprocal. Okay? So it's 2 squared under the number 1, which is 1/4. Okay? And you have lots of exercises to work on in your group right now. Do the best you can to get through them. Okay? Oh, okay.
Use it with like a square root symbol.
Can I use
a different form of that same? Like can you do with the square root symbol instead of exponents?
Yes. You mean could you rewrite this as this cubed root of 8 to the -2? Absolutely. That's why I showed you this way too, because some people will convert these to radicals instead of staying with. Is that what your question is?
I think they're asking, will you do that?
Well, no. That's what they're asking. No, you figure out whatever way works best for you. So you got a bunch of problems right here. We didn't cover adding and subtracting. That's in your book. But maybe if these fractional exponents bug you, then come down here and start working on 13, 17, and 18, and 15, and 14. Come down here and work if those are bothering you a little bit. Now, there's one little mistake in the answer key here. Look, right down here, you see how number 2 says 3 times s? I used these problems in Math 106 last semester when we didn't have the absolute value. That should say 3 times the absolute value of s. So you want to change that answer. It's at the bottom of the page. So unfortunately, I'm sorry I only left you 6 minutes to work on these, but do your best, talk about them. Yep. Well, I got Sonia first, and then I'll get you.
I just have a question. Are you expecting whatever we don't do in class to also have this?
I think it's a good idea, but I'm not. The only homework grade that I collect is what's on there. I think that this would further help your understanding.
But it's something that we can do at our own
Right,
time.
yeah,
It doesn't
yeah,
affect
right.
our grade.
No, I don't give out extra homework. No, I don't give.
Like if you wanna, like if I said, hey, I'm having trouble with this, can you give me extra problems?
Oh, I can just point you to the whole section in like a Math 106 book in the studio. Yeah.
Okay.
Or any books in there, and there's also places you can go on, Khan Academy. There's
Oh yeah.
yeah, and then there's something, if I can remember how to get in there. I have a program where I can generate more problems. but it's been like 4 or 5 months since I've used it, so I've got to see if I can redo it. This is all this is like from my 106
Yeah,
class, all
yeah.
106 stuff. But it's hard when you haven't had it for a few months, to
Yeah, I
remember.
took the summer off of
Yeah,
that.
yeah.
We all did.
Right, but it will come back. It will come back.
Typically, we just have extra work that we can do.
You can or not, you're going to see those same things for homework. Okay, so if you just get the homework done and understood, you don't have to, the reason why we would have had time to get here, but I'm starting this new thing here, so that took time to talk about some things, and I think it's important, because then it
Yeah, no, that was
reinforces
great,
it,
answering the questions.
Okay, so well, let me show you this, again, there's 2 or 3 ways. There's 3 or 4 ways, and that's part of the problem. The thing you have to remember is that you have 1, 2, 3, you have 3 separate actions you have to do. And it doesn't matter which order you do it. Sometimes one order is easier than the other. I always start with whatever my root, if my base is not a fraction. So I'm going to show you 2 different things. If I started with this, I'm going to show you a little different order. Okay? If I start with a fraction, then the first thing I'm going to do is flip the base. That would be the first thing I do. And the reason is because to get negative 2/3, you could do like this. You could say 1/3 times 2 times negative 1 in any order you want. That's what negative 2/3 equals. You could square it first, then take the cubed root, and then flip it. You could take the cubed root first, you could flip it, and then you could square it. It doesn't matter which order, because you've got 3 different things here you have to do. You've got cubed root, you've got to square it, and you've got to take the reciprocal of your base. So you've got to take the cubed root, you've got to square it, because that's what 2 in the numerator means, and you have to flip it. Okay? And it doesn't matter. So let me, and the reason it doesn't matter, Megan, is you can write negative 2/3 as a multiplication problem of 3 things in various ways. Okay? So let's take the cubed root first. The cubed root is this. Then we'll square it, and then we'll take the flip. So let's do this. Let's work inside. 8 to the 1/3 is the cubed root of 8. And what is that? 2. So this becomes 2. Now, 8 to the 1/3 is 2, because it says, what number do I cube to get 8? It's 2 times 2 times 2. That's 8. Then you square it, and then you're going to flip it. So now let's square 2, 4. And now let's take its reciprocal, 1, 4. Negative 1 just means reciprocal, 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 reciprocal. So you just take the reciprocal. Some students like to say flip it. The only reason I don't like that so much is sometimes students flip the exponent. You never touch the exponent. All right? Now, here's another way to do it. You could write 8 as a, if you look at this root here, 8 is a perfect cube. So look at this. This is like the easiest way to do it, but it's the way that students, now it's the exponent property. You multiply those 2 exponents. Here are your 2 exponents. 3 times negative 2/3. Your 3's cancel, so you get 2 to the negative 2, which is 1/4. Okay, it's just another way. If you start off with a fraction, I would do this part first. I would take care of taking the reciprocal of this and get rid of that negative exponent. So I would turn that into 8, and then it's just 8 to the 2/3. Yeah. No, it's done. You've taken care of it. You've taken the reciprocal. Okay, now you take the cubed root, which is 2, and then you square it. Look at these 2 original problems, Megan. They have the same exponent. What's the only difference between them? The number you start off with here is 8. The number you start off here is 1/8. Those are reciprocals of each other. The answer here is 4. The answer here is 1/4. They're reciprocals. Okay. Negative exponents mean reciprocals. Okay. How are we doing over here? Oh, time to go. All right. I'll see you all on what day? Monday.
We have 2 things online we're doing.
Wednesday. 2 classes. Yep.
Okay.
The next
Well, this is really group work. I think if you get your homework done and you want some more practice, this will be helpful. Oh, yeah. If you want to see what our Moodle site looks like, folks, woohoo! Hang on, I forgot to show you this. If you have 2 minutes, I want to show you where our class videos are on Moodle. Here's Moodle. When you sign into Moodle, let me sign in real quick. We'll take literally 1 minute to show you guys this. This is kind of exciting. I've totally changed. I'm putting myself on YouTube. If you put Linda Kavanaugh with a space and small letters, I'm about the 11th Linda Kavanaugh down. But if you go to our Moodle site, here's our class. Nathan, I can't talk over folks. Okay, here's our class. And here's a little intro with all our course. We're always going to have class notes. You'll always have class notes based on which test you're going to be taking. So if you look in here, this is what the lecture notes you have right now in your hands, okay? And then next week, there'll be the next week's lecture notes. Your class A, because you're the 8 o'clock, if you hit this link, it takes you right to YouTube. There I am. And there is the video from Wednesday's class. You just click on it. It's so cool. Or you could put this right here, no spaces, Math 107A, Class 1, Fall 13, right into YouTube. You don't even have to go to Moodle. Boom, you have the class. Okay? And today I'll put our class in here at the end of the day. So you'll have both videos. Sonia?
Just to be clear, we have another, my math lab homework assignment today?
Yes, Class 2's homework
So
assignment.
we have a session Wednesday?
What?
Did you say we have an exam coming up?
Quiz next Wednesday. Right. And it's on which 2 classes? Wednesday and Friday, today, yesterday and today, or Wednesday and today's. That's what the quiz is on, and the homework that you've been doing, and the reading.
So P1, 2, 3.
Right, absolutely, right. So if you finish your 2 homework assignments by the weekend, you're done for what you need for the quiz. Okay?
I was just going to ask about the homework. Do you recommend doing the homework like right after, as soon?
Yeah.
Okay, because I tried to do it last night and it was taking a little bit longer than I was
Yeah.
anticipating.
Yeah.
I don't want to, start
No,
behind.
no, yeah. Like I said, that's why I give you that time. I don't want to penalize you if you can't do it right after class, because you got other classes, you got work, you got whatever. But trying to stay on top of it is kind of critical, especially as we get to new stuff, and what we do one day is important to learning the stuff for the next class.
Okay.
But no, there's no, you got all weekend, okay?
So there's something I'm not quite understanding about Xbox.
Okay,
And-
yep,
All right, so if you have like 8 to the -2,
yeah,
it's the same as saying 8 to the 1/2.
yeah, no, you don't flip that. You
Flip
never,
that.
you flip the base, yeah. Yeah, and that's the one mistake a lot of students make. This says,
Got it. So
you never touch, well, here's how you can touch it. -2, do you agree I could write this way? Or I could write -2 this way? Okay, so I could rewrite that like this. 8 squared raised to the -1 power, right? Because when I raise,
okay,
right?
yeah.
Or I could write it this way. Yes? So this says 64, take my reciprocal. Or this says 1/8. That's the only time you can affect the base. Okay, but you
Gotcha.
never change the
Never
exponent.
changes that.
Right. Okay, good question.
Okay, so after each class we have a math lab, right?
Yep. You too, Logan.
Anything else after class, like Or is it just like during the class we do the anticipation? So the class starts, we do this.
Yeah,
right?
you come in with a
And
question,
we
yeah?
do the anticipation.
Yeah.
We do a math
Right.
after class.
Right.
And then and until the next class, other than the math lab, there's nothing to do, right?
Oh, you got to read. You got to read your book always. And, you know, whatever sections we're covering, because like I told you, P2 is all self-review, so you got to read and do, right.
Yeah, because I know I can find the book online. There's a
Right.
book,
Yep.
You know, so I'll just do that. So just math lab. Read
Right.
the
Well, when you
section.
get your access kit, when you go down and get your access kit for this class, you have to put in, where's your syllabus?
What's that access kit?
That's the code for you to go into my math lab.
So
You have a class code to get into my class, and then you need a code to get to do the homework. So you have to
we have to buy.
you have to buy something, right? You can go online for 17 days free into my math lab, and you have to use the code in the syllabus. So you can hang out in my math lab for 17 days before you have to pay, but at some point you will have to make a decision whether to use just the e-textbook or whether to get those other two versions. But the only way you can do the homework is by paying for that code. It's around $90-something. Now, some people have been able to find on Amazon for $20-something a book that hasn't had the access code used. So that's another thing you could try. But you're going to need to use, where did I put the code? Right here. This is how you can go on. So you put this code in. Oh, I gave you B. We're A. I gave you B. You're not B, you're A. Shoot. Do I have any more A's? Oh, I gotta. Oh, I can't. Yep, I gotta give you a.
Purchase any of my books till next paycheck.
That's all right. You can do this free. Oh, good. Thank goodness. Here, I got to switch with you here. So you just go in here. You do all this. You put that in. You click you're a student. You put that in, and then you create an account. And one of your options will be to do a free trial for 17 days. Okay. And then you'll have plenty of time before your check comes in to continue to do the homework. That's the nice thing about this. Okay, there you go. Thanks. I'm so glad I caught that, because you wouldn't have been in the right class. All right, good.
Yeah, that's my only. I think I'm gonna be good. It's just I didn't like. I went to ACC.
Yeah.
So at ACC, they do no book.
Oh, that's.
They don't do that.
Oh.
So